Okay, so electromagnetic surveying. Is anyone familiar with it, seen any of the maps or seen how it's used at all? No, so it's all completely new. Okay, so the background to the technology is that there's a whole range of different EM sensors that are out there. This one is called an EM31. Michelle was saying that she'd shown you in class at some stage about an EM38, which is a little short orange unit. There's EM34s and 64s and all kinds of different sensors. The difference between all the sensors is the difference, basically the length of them, and so the distance between the transmitter and the receiver. So this particular unit here has got an electromagnetic transmitter at one end, which emits an electromagnetic pulse. As that pulse goes down through the ground, it induces an electrical current, and the strength of that is measured by the detector at the other end. So this particular one measures the conductivity down to a depth of about 6 metres. The EM38 goes down to a depth of about 1.5 metres. You can put these things on, well, there are different sensors that get mounted on helicopters or even light aircraft, where I think it's the detector is on a cable and it basically gets wound out the back of the plane. So once the plane's up and flying, they just wind it out the back. And so the detector might be 200 or 300 metres behind the plane. And in that configuration, they're actually able to look sort of 300 and 400 metres down through the soil to come up with an average conductivity profile. There's also a relatively recent development where the companies are starting to put multiple transmitters and detectors in a particular unit, and so there's one unit we've started looking at recently that'll actually allow you to do 6 simultaneous depths. So you can do 50 centimetres, 1 metre, 1.50 metre, 2 metres, 3 metres and 6 metres in a single pass. And so that not only allows you to determine what the average conductivity for the profile is, but it tells you how things change down the profile, and so that can be a really helpful thing. The sensors themselves, does anyone know what it's actually measuring? No. So it's the amount of salt that's in the profile. So while it's transmitting an electromagnetic pulse, it's the amount of salt that is in the soil profile that determines how strong the electrical current is. And does anyone know why measuring the amount of salt can be important for determining soil characteristics? Like salt itself is an issue, but there's actually a bigger soil parameter that's critical. No thoughts? In this case, it's actually the drainage characteristics. Because if you think of, at some point way back when, most of this area was under an ocean or under the sea, and so when the seas receded or sort of changed, left a layer of salt right across the landscape. So we started out from a very salty base, basically. And so then over thousands of years of rainfall, an area that had good soil drainage will have allowed more of the salts to just wash down through the profile. An area that had poorer drainage, which is going to tend to be an area that's got more clay, will have retained more of the salts. And so it doesn't necessarily mean that the soil is salty from the point of view where it's going to be detrimental to plant growth, but basically every soil profile will just have the smallest amount of salts in it. And so it's the drainage characteristics that have largely influenced how, what that sort of residual amount of salt is going to be. So when we've got a sensor like this hooked up either on a quad bike or behind the ute, hooked up to the GPS as we're driving along, every second it's doing a reading. And so then at the end of the day, we can collect all that data together and generate a map similar to this thing here, which basically shows us that in this case, this is an area of low conductivity. These red areas are areas of high conductivity. And in most instances, you can't just look at the map and say whether that's a good area or a bad area. The map's just telling you that they're different areas, because different applications will require either high conductivity or low conductivity. If you're trying to grow a rice crop, then you want the conductivity to be quite high, which is indicating that's a really strong clay profile, and so you're going to retain the water. But if you're trying to do some kind of horticultural application, then you want the soils to be really well drained. So we need to try and avoid sort of generalising that high conductivity is bad or low conductivity is bad. Basically, different applications have different requirements. And certainly that's one of the things where, as well as being able to do field surveys, and so in this case, you know, we've gone up and back across the whole paddock and identified where there are broadly different areas of soil conductivity. And so then someone with the agronomist or the consultant or the farmer, whoever, goes out with the soil sampling gear and takes a number of soil profile cores in the low conductivity area. Then you go to the medium conductivity area and the high conductivity area, and generally you'll find there's some kind of gross soil difference between those different zones. Then based on the soil testing, you can come up with some kind of strategy. In a lot of instances, that might just be a nutritional thing, that you might find that the high conductivity areas have the highest amount of soil nitrogen, for instance, and that the low conductivity has got the lowest soil nitrogen. But that doesn't necessarily mean that the lowest conductivity, lowest nitrogen is the area that needs the most fertiliser, because it could just be that low conductivity is there because it's a really shallow and poorly a soil with a low potential, and that putting more nitrogen on that area is actually a waste of time, and that the high conductivity patch, which is a heavy clay, already has more nitrogen than anywhere else, but it also has more potential than anywhere else. And so in that situation, you actually might want to put more fertiliser where the most fertiliser already exists. In other situations, you will put the fertiliser in the area that's got the lowest amount of nitrogen. And so that's where you can't just take one number and jump to a conclusion about what you're going to do. There's a whole series of understandings and context that needs to be given to the situation before you can determine what is the most appropriate action to be doing. It's certainly amazing when we take the map like that and load it up onto the navigation screen and you put it in the front of the vehicle and you're driving around, that it's amazing how often when you pull up in a particular spot, you know, the farmer will recognise that this particular patch is always, you know, that's where he always gets bogged, or, you know, there's always poor germination, or it's a weedy area, or it's a good area, it's a bad area. That the farmers most of the time will recognise different crop characteristics that correlate to the patterns in the paddock, and that can be a great thing, because while it's not necessarily identifying something that's new to the farmer, what it's doing, it's come up with a quantifiable map that actually shows the distribution. That the farmer might always be able to tell you that, you know, the bottom corner of the paddock is, you know, isn't as good as the rest of it. With the map like this, you might actually be able to, you know, draw the line and say, well, okay, it's actually 36% of the paddock. It's not just the bottom corner. And so it allows to quantify a lot of things that the grower might already have been seeing, and it might also identify that, as well as that general trend, there are some other patches in the paddock that are very similar to that soil as well, that, you know, that perhaps the farmer hadn't sort of quantified the impact that was having. The other kind of application for the technology, and particularly in relation to drainage characteristics, is where we start thinking about irrigation infrastructure. And so one of the jobs that we've got going at the moment, or hopefully about to be starting, is where instead of doing a field survey, we run around in either the bottom of dry channels with the quad bike, or if the channel system is full, then we've got a customised floating survey unit. Essentially, it's 2 bits of 400mm black poly sort of, you know, joined together with an outboard motor, and basically just go up and back inside the irrigation channels. And because the sensor, this particular sensor, is sending out a signal to a depth of 6 metres, as long as the water's less than about 2 or 3 metres deep, we're still getting a good soil profile assessment. The water itself is basically invisible to the sensor. But when we do that, we can actually then come up with a map like this one that shows where the patches of low conductivity are, which are likely to be the patches or the sections of the channel that are leaking water. And we've certainly done jobs in the past where where growers that know that they're losing 20 to 30% of their water every day, just disappears out the bottom of their channel system, but they can't tell you where in the channel system it goes. And so we've done jobs like this where we've gone out and done the conductivity survey. Then as part of the ground truthing of the data, and that's the thing with any of these types of spatial information, you have to go out and investigate what it is that's causing the problem. But we've gone out with an excavator and found a section or an area of low conductivity, blocked the channel either side of that, and within, in one particular case, within 36 hours, the low conductivity section of channel was completely dry. And so we'd had a metre and a half, when the channel was full, it was 1.5 metres water deep, and that water had completely drained out the bottom of the channel in less than 36 hours. Immediately adjacent that, in the higher conductivity, the water level was completely consistent. And so that was corresponding to, I guess, 3 or 4 megalitres per kilometre per day was the rate that the water was just disappearing out the bottom of the profile. And so yeah, so that kind of application is there as well. So there's lots of irrigation sort of infrastructure assessment. We certainly did do a lot of irrigation dam sites. So before someone wants to build an irrigation dam, the historical practice was to get an excavator or backhoe and go and dig half a dozen soil pits, have a look at the soil, decide whether or not it was suitable for building the dam, and then off they'd go. But that might be using 5 or 6 individual locations to make a decision about a 100 hectare dam site or a 200 hectare dam site. When we're doing this kind of survey, we might be doing 150 readings per hectare across the whole site. So, and it's a purely objective assessment. The sensor's just measuring away, and it then tells us where the highest conductivity, the lowest conductivity, the average conductivity zones are, and we can go out then and dig the holes in specific locations. And you can have 2 soil pits that might only be 20 metres apart. One of them is clay the whole way. The next one hits pure sand at 50 centimetres. And on the surface, it all looks the same. And so depending on where you've taken those, you can dramatically bias your assessment of the site. With the sensor like this, you can come up with quite a detailed map of what the site looks like. And we've also used it for a whole heap of other crazy type jobs, measuring road bases and sporting fields and things like that. We did a survey a few years ago in Sydney where, as part of there's a big push in urban environments to be recycling water and sort of treated sewage and things like that. And so whenever any of the councils in Sydney want to look at a water recycling program, they need to have a soil map before they can determine whether a site's going to be suitable for taking effluent. And so we did a job in the Cronulla or the Sutherland Shire a few years ago where we actually went and surveyed, I think there was 15 different sporting fields and school grounds and golf courses and things like that. And so one of them was Shark Park. And so it's really quite weird to be sitting on a quad bike with this sort of gear going up and back while the first graders are training at the other end of the paddock and things like that. And so yeah, it's more than just an agricultural application. Quite a few years ago there was a big landslide up at Thredbo that wiped out a couple of ski lodges, killed a few people, and that was found to be because of an unstable soil base. And so we came in a couple of months after that and surveyed the entire road network. So another weird job where we were riding around in the quad bike in the snow, basically going up and back on all of the roads to identify where there were differences in the soil characteristics along a section of road. So we weren't necessarily looking for high conductivity or low conductivity, we were just looking for different. And it's a terrific sensor for being able to do that, because you're driving along, taking a reading every second, and you'll find these little sections of 10 metres here and 20 metres there, where for some reason the soil underneath the road was just quite different to the rest of it. The road guys would come in, dig their holes, have a look at it, and make adjustments to the road base. So there's all kinds of different applications for the technology, largely wherever drainage characteristics and soil texture are seen to be of some kind of importance. One of the questions last time round was in relation to the GPS gear that we use while we're doing this. And so what we've got here is our GPS, and you'll hear a bit more about GPS when you get down to talking to the tractors in a moment. But this is it's a survey grade RTK GPS system. So this particular unit, this has got a quick mount there, so we can mount that on either the quad bike or the Land Cruiser or tractor, whatever we're working in. And so it's able to measure the coordinate accuracy at about 10 mil sort of accuracy. If we're within a certain distance of the base station, that can get down to sort of 5 or 6 mil accuracy. The antenna on the right up there is my base station. So there are lots of different ways you can get an RTK subscription. You can get a service from either a satellite, from a local permanent base station, or if in our situation, because we're working in so many different parts of the world, we just take our own base station with us. So when we get to a particular job, we can set that unit up either on the vehicle or on a tripod or a fence post or whatever, and set it up, turn this thing on, and off we go. And so yeah, it's a pretty straightforward process for doing that. It's a relatively expensive process, so looking at replacing the EM gear at the moment with one of these new sensors that'll do 6 individual depths, and you're looking at about $75,000 for the sensor. This particular rover unit is about 50 grand. The base station is about 25 to 30 grand. The navigation gear that we put in the Land Cruiser on the bike, so it's about a 13-inch touchscreen monitor, exactly the same units that they put in the tractors for the steering. That's the same guidance system that we use. I was actually talking to some guys the other day about whether or not we can actually hook it up to the steering, and while it's definitely not a legal thing to do, you can, if you really want to, hook up the steering and basically have auto steer on the Land Cruiser when you're in the paddock, which would be a pretty neat way of doing it. But yeah, it's a pretty expensive set of equipment to be putting together, and so there just aren't many people that do this sort of stuff. And so we do work pretty much all over Australia, and every couple of years get jobs overseas. So we've worked in Africa and India and Bangladesh and the Philippines and New Zealand, and yeah, it's really weird when someone rings up and says, "We heard you guys do this. Can you come here and do it?" And so yeah, so it's been a very different pathway of work and experience from where we thought we were going to go. When we set up 15 years ago, we just assumed we were going to be helping farmers in this district make nitrogen recommendations. And so yeah, to be working on international projects in Mozambique and things like that wasn't something that we were planning. One of the potential jobs that we've got coming up later this year and over summer is a really large EM survey of 3,000 kilometres of irrigation channels. And so I'm actually looking for some casual workers for over summer if that project gets up. Yeah, the warning is that we've actually got to do, it's 3,000 kilometres of irrigation channel, and we've got to go up and back. So that basically it's a 6,000 kilometre journey in an irrigation channel sitting on top of a couple of lengths of PVC with an outboard motor. The first 20 minutes or so, it's hilarious, it's a lot of fun, you're roaring along, you're thinking this is great, and then you hit your first obstacle. And basically every kilometre or so there's a fence or a bridge or a culvert or a monitoring device, and so basically the unit has to go in and out of the channel every kilometre as we're doing that. So we've got a neat custom built trailer with a hydraulic crane and all the rest of it, but ultimately it takes a crew of 3 to make that all happen. You've got to process out the GPS data and the EM data and all those sorts of things at the end of each day, and so yeah, potentially there's going to be just it's going to take a stack of work to get it done. So if anyone's interested, or even for any other holiday work, so I've always got different farm surveys and things going on, and so if as part of your prac work and all the rest of it, you're interested in a couple of weeks paid work, using GPS and mapping and going out and digging soils and all that sort of stuff, then yeah, let me know, get me your details, and as stuff comes up, we can see what happens.
Where is that project at?
Down in the Murray Valley. So whereabouts are you from?
Tokemon.
Oh, okay, yeah. So yeah, it's the entire network has to be done. So yeah, so starting with the main supply channels,
Yep.
and then once that's done, getting out and doing all the secondary stuff. So yeah,
Okay.
it's going to be a thing.